Welcome to MRL. In this learning session, we'll be learning the solutions of the examples of the end of the chapter exercises of Ganita Manjari 9th standard NCERT textbook. This is the second video of the same exercise. In the first video we have learned the example, that is first 16 examples we have learned in the first video. Now we are going to start with the 17th example. Now in the 17th example we are given circle with center O, it is given to us. Chords AB and AC are congruent, chord AB and AC are congruent. Now we have to prove that the center of the circle lies on the angle bisector of angle BAC. We have to show that the center of the circle lies on the angle bisector of the angle BAC. Now for the proof, let us go for the construction. Let us join OA, OB and OC. Let us join OA, OB and OC. Now in triangle AOB and triangle AOC, two triangles are there, AOB and AOC. AB is equal to AC because they are chords which are equal, given to us. Now OB is equal to OC radii and OA is common to both the triangles. That means these two triangles, that is AOB and AOC, are congruent by triple S congruency criteria. If two triangles are congruent, then corresponding angles are equal. That means angle BAP, because we have angle BAP is equal to angle CAP. So we have got angle CAP and BAP are equal. That means AP is the angle bisector of angle BAC. Now the angle bisector AP passes through the center O of the circle, That means the conclusion is the center of the circle lies on the angle bisector of angle BAC. So that is what is the proof of this particular example. Now the second example is, we are given a chord AB 10 centimeters, that is phi and phi, AN is phi and BN is phi, that is N is the midpoint, so AB is 10 centimeters. Chord CD is 24 centimeters and M is the midpoint, therefore CM is 12 centimeters and DM is 12 centimeters. Now the chords are lying on the same side of the center of the circle, both AB and CD are on the same side of the center. Now the distance between the chords, that means the distance between the chord AB and CD is 7 centimeters. Now what we have to find is the radius of the circle, that is OC or OA. Here OC is R and OA is also R. We have to find the radius. Now if you consider the triangle OCM, this triangle OCM, then OC square is equal to OM square plus CM square. So we have got OM square plus CM square. Rather R square is equal to OM square plus CM square. That is R square is equal to OM square plus 12 square, or R square is equal to OM square plus 144. That is equation number 1. Now if you take the second triangle, that is triangle OAN, then OA square is equal to ON square plus AN square. But AN is phi, therefore OA square, which is R square, is equal to 25 plus what you call ON square. So 25 plus ON square, 25 plus ON square. Now that is equation number 2. So we have got two equations here where LHS is R square. So equating RHS, we get OM square plus 144 is equal to ON square plus 25. Now rearranging these terms, moving from left to right and right to left, we get ON square minus OM square is equal to 144 minus 25. Now ON square minus OM square is A square minus B square form, so we can write it as ON minus OM, ON plus OM, and 144 minus 25 is 119. But we know that ON minus OM is 7 centimeters, therefore I have taken ON minus OM as 7 centimeters into ON plus OM is equal to 119, or ON plus OM is equal to 119 by 7, or ON plus OM is equal to 17, or OM plus MN, and plus OM. Why? Because we know that ON is equal to OM plus MN, ON plus MN, that is what I have substituted here for ON. So OM plus MN plus OM is equal to 17, OM plus OM is 2 OM plus Mn is equal to 17, and we have Mn is equal to 7 there, so substituting the value of Mn as 7, so 2 times OM is equal to 17 minus 7, and that is 10, therefore OM is 10 by 2, OM is equal to 5 centimeters, so we have got OM as 5. So once we get OM as phi, then we can find out the radius very easily. So we know that r square is equal to phi square. R square is equal to phi square. We can take this. R square is equal to phi square plus r square is equal to phi square plus 12 square. R square is equal to phi square plus 12 square. R square is equal to phi square plus 12 square, and therefore r is equal to 25. R is equal to 25 plus 144. R is equal to 25 plus 144, and that is equal to 169. Therefore r is equal to square root of 169, or r is equal to 13 centimeters. Remember that. Now the next example is, that is the 19th example. We are given a regular hexagon. Please make a note here. It is not only a hexagon, it is a regular hexagon. A regular hexagon is inscribed in a circle of radius r. The radius of the circle is r. A hexagon, which is a regular hexagon, is inscribed, and we have to find the length of the sides of the hexagon and also the distance of each side from the center. Now the solution is very simple. We are given a regular inscribed hexagon which has 6 vertices, and when the vertices are joined to the center, we get 6 triangles, and all the 6 triangles are congruent triangles, and they are equilateral triangles. Rather, each of the angles of the triangle is 60 degrees, and the 6 triangles are equilateral, and if they are equilateral, all the sides are equal. That means each side of the triangle is r units. Therefore the length of the side of the hexagon is r units. So very simple. Now we have to find the second point, that is the distance of each side from the center. To find the distance from each side, we have the side of the hexagon here, that is AB is equal to r centimeters, or half of AB, that is P is the midpoint. When I draw a perpendicular OP here, then AP is r by 2, BP is also r by 2. Now we have to find the distance OP. OP is the perpendicular distance. We have to find OP there, and OP can be found out by taking the triangle OPB. OPB is the right angle triangle. Now OB square is equal to OP square plus PB square, and OP square is r square. We have got OB square is equal to r square plus OP square plus r by 2 whole to square. So we have OP square is equal to r square minus r square by 4, and OP square is equal to, taking the LCM, 4r square minus r square by 4, or we get 4r square minus r square is 3r square by 4, and to find OP I have to take the square root of that. So OP is equal to square root of 3r square by 4, or OP is equal to square root of 3r by 2. Therefore the answer is OP is equal to root 3 by 2 into r, and that is what is the distance of each side of the regular hexagon from the center. Therefore the conclusion is, the length of the side of the hexagon is the r units, and the distance of each side from the center is root 3 by 2 into r. So remember that. Now coming to the next example, that is example number 20. We are given a quadrilateral, we are given a quadrilateral here, MNOP, and it is inscribed in a circle. Mn is diameter. Now here he is asking, what is the relation between MOP and MNP? That means, and we have to justify it. So let us talk about MOP first. So we take MOP. MOP is the central angle subtended by the chord MP. MOP is the central angle subtended by the chord MP. And also MNP. MNP is again the inscribed angle subtended by the same chord MP. So MP subtends central angle MOP, and also the inscribed angle MNP. And we know that the central angle is twice the inscribed angle, and therefore we find that angle MOP is 2 times angle MNP, because the angle subtended by an arc at the center is double the angle subtended by the same arc at the circumference, and PM is the chord, or PM, arc PM is also, we can take the arc PM also. Whether we take the chord or the arc PM, the relation is the same. Therefore angle MOP is equal to 2 times angle MNP, and that is the relation. Try to remember that. Now coming to the next example, that is 21st example. We are given ABCD is a cyclic quadrilateral. Now we have to prove that the exterior angle of a cyclic quadrilateral is equal to the interior opposite angle. So let us try to understand this. Now ABCD is a cyclic quadrilateral. We have extended here, we have extended AD here, not CD, please correct this. AD is extended to E. AD is extended to E. When I extend AD to E, then I get an exterior angle CDE. So CDE is the exterior angle. We have got the exterior angle formed is CDE. Please understand, it is not A, the CD is the exterior angle here. So that is the exterior angle formed is angle CD, that is correct. CD is the exterior angle formed, and angle ABC is the interior opposite angle. So please understand, CD is the exterior angle. For this angle CDE, the interior opposite angle is angle ABC. Now we have to prove that exterior angle CDE is equal to interior angle ABC. Now it's very simple. Now let us consider the angle CDE plus angle ADC. They form a linear pair. Therefore angle CDE plus angle ADC is equal to 180 degrees. That is a linear pair. And also we know that angle ABC plus angle ADC are the opposite angles of a cyclic quadrilateral, and that is also equal to 180 degrees. Now RHS of both are 180. I can equate the LHS. That means CDE plus angle ADC is equal to angle ABC plus angle ADC. ADC will cancel. We get angle CDE is equal to angle ABC. That means we have got angle CDE is equal to angle ABC, and that is exactly what we wanted to prove. That is, the exterior angle of a cyclic quadrilateral is equal to the interior opposite angle, and therefore exterior angle of a cyclic quadrilateral is equal to the interior opposite angle is what is the conclusion of this particular theorem. Try to remember that. Now the next example is the 22nd example. The statement is, there is no chord of a circle that is longer than its diameter. There is no chord of a circle that is longer than its diameter, and we have to justify the statement. The statement is very simple. It means that in a circle the longest chord is the diameter. There is no chord longer than the diameter. Let us see how to justify this. Now the longest chord of a circle is the line segment. The longest chord of a circle is the line segment passing through the center of the circle. The longest chord of a circle is the one that has the distance from the center as 0. That is true. The diameter is the line segment that passes through the center of the circle and joins the 2 points A and B in a circle. The diameter is the line segment that has 0 distance from the center. That means the chord and the diameter is the same, and therefore the longest line segment in a circle is the diameter. Therefore the longest chord in a circle is the chord, which is nothing but the diameter. Therefore the longest chord of a circle is the diameter of the circle. That is what you have to remember. But if you want to prove it logically, I will go for logical proof also for this. Let us consider a circle with center O. AB I have taken as a chord. Now join OA and OB. Now AOB I get a triangle. Now in triangle AOB we know that the sum of two sides is definitely greater than the third side. That means OA plus OB is greater than AB. That means OA is R and OB is R. Therefore AB is less than 2R. So therefore we have got AB is less than 2R. That means 2R. AB is a chord which is less than 2R. Now if I start increasing the length of the chord AB slowly and reach to the diameter, now we have the chord PQ here, and the chord PQ is the length of the chord PQ is OP plus OQ. OP is the R radius, OQ is also the radius. Therefore the length of the chord PQ is equal to 2R, and that is nothing but the diameter. So PQ is the longest chord and PQ is also the diameter, and the length is 2R. That means the longest chord possible in a circle is the diameter only, because the longest chord PQ, the length is 2R and 2R is the diameter. Therefore there is no chord of a circle that is longer than its diameter. So try to remember this logical proof. Now coming to the next example, that is example number 23. We are given a circle with center O. A is any point inside the circle. So we are given a circle with center O, and A is any point inside the circle. Now what we have to prove is the shortest chord that passes through A. The chord that passes through A is the one that is perpendicular to OA. The meaning is, there is a circle with center O. A is any point inside the circle, and there is a chord PQ which passes through A, and OA is perpendicular to PQ. That means we have to prove that PQ is the shortest chord which passes through A, and that is at a perpendicular distance. OA is the perpendicular distance, so that is perpendicular to OA. So the chord PQ is perpendicular to OA, and that is the shortest chord, is what we have to prove. Now the proof, I can do it by contradiction method. So let let us consider that PQ is not the shortest. Let RS be the shortest, and therefore let us take chord PQ not to be the shortest through point A. Let RS be the shortest chord through A. RS be the shortest chord, chord through A. Now draw OC perpendicular to RS. In triangle AOC, it is a right angle triangle. Definitely OA is the hypotenuse and OA is greater than OC. OA is greater than OC, and if OA is greater than the OC, that is OA is the hypotenuse, and therefore the distance of the chord PQ, the distance of the chord PQ from the center is greater than the distance of the chord RS from the center. OC is smaller than OA, or OA is greater than OC, and therefore the distance of the chord PQ is greater than the distance of the chord RS. Rather, RS chord is greater than PQ, and the only chord which is shorter than RS is PQ, or PQ is the shortest chord which is passing through A and perpendicular to OA, passing through A and perpendicular to A, and therefore the conclusion is the shortest chord that passes through A, the shortest chord that passes through A is the one that is perpendicular to OA, is what is the proof of this particular example, and try to remember that. Now coming to the next example, that is 24th example, we are given a figure here, and in this figure we are also given some certain angles. We are given the angle OBA as A, OCA as B, and we are also given that OB, OA and OC are equal in length. Now we have to find out, what we have to prove is that the angle BAC is 90 degrees, or the angle in the semicircle is 90 degrees, using the information what is given to us. So let us see how to do that. Now in the figure, OA is equal to OB is equal to OC. That means all these sides are equal, but we know that the angles opposite to equal sides are equal. Therefore, if OBA is A, OAB is also A. Similarly, if OCA is B, then OAC is also B. Now take the triangle ABC. In triangle ABC, angle A plus angle B plus angle C is equal to 180 degrees. That means angle A, that means A plus B plus B is equal to 180 degrees. 2A plus 2B is equal to 180 degrees, or A plus B is equal to 180 by 2, or A plus B is 90 degrees, or angle A plus B is A here, therefore angle A is 90 degrees, or the angle in the semicircle is 90 degrees. Try to remember that. Now the next example, that is 25th example, is we are given a circle with the center O. I have not marked O here, please mark it. So we are given a circle with center O. AB is the diameter. AB is the diameter passing through the center O. CC dash, this is CC dash here, and DD dash are chords. They are chords, definitely they are chords, and they are drawn perpendicular to the diameter. So CC dash is a chord perpendicular to the diameter. DD dash is also a chord perpendicular to the diameter AB. Now if CC dash and DD dash are perpendicular, that means CC dash and DD dash are parallel to each other. Now what we have to prove here? Now we have to prove that the line segment MM dash joining the midpoints of the sides CD and C dash D dash is parallel, or is perpendicular to the line segment AB, or to the diameter AB. Now to do that, now we know that AB is diameter, CC dash is perpendicular to AB, DD dash is perpendicular to AB, that means CC dash and DD dash are parallel to each other. Now one pair of opposite sides are parallel in this particular quadrilateral. Then that means CD and C dash D dash are non-parallel sides. This is a trapezium, and in a trapezium the line joining the midpoints of the non-parallel sides is definitely parallel to the two parallel sides, that is CC dash and DD dash, and therefore MM dash is parallel. MM dash is parallel to CC dash and DD dash, and if it is parallel but natural, it is perpendicular to the line segment, that is the diameter AB. So MM dash is perpendicular to AB. So please remember this, that the line segment MM dash joining the midpoints of the the chords CD and C dash D dash is perpendicular to the diameter, or the line segment AB passing through the center O. So that is the answer for that. Now coming to the next example, that is 26th example, we are given a figure, and again in this figure they have given a cyclic quadrilateral ABCD, and we have also been given the angles OBC as Q, OCD as U, ODA as V, and the OAB as P. Now, and also they have given that what is given, it's also their radius rather. OB is equal to OA is equal to OC is equal to OD, and that means if you take each of these triangles, we find the angles opposite to these equal sides are equal. If this is P, this is also P. If this is Q, this is Q. If this is U, this is U. If this is V, this is also V. So we have the angles opposite equal sides are equal. Now we know that angle A plus angle B plus angle C plus angle D is 360 degrees. That is the angle sum property of a quadrilateral. Now that means I can add P plus Q plus Q plus U plus U plus V plus V plus P equal to 360 degrees. Now P plus V plus P plus Q plus Q plus U plus U plus V is 360. Now that means P plus P is 2P, and we have Q plus Q is 2Q, then U plus U is 2U, V plus V is 2V is equal to 360, or I can divide throughout by 2, therefore we got P plus Q plus U plus V is 360 by 2, that is 180 degrees, and P plus Q, if you observe, P plus Q is B and U plus V is D, that means angle B plus angle D is equal to 180 degrees. That means the sum of the opposite angles of the cyclic quadrilateral are supplementary, and that is what we had to prove. And also if you rearrange this and add, we get P plus V is equal to plus Q plus U. P plus V is A and Q plus U is C, therefore angle A plus angle C is also equal to 180 degrees, and that is exactly what was the proof asked, and we have proved it. So that these were a few important examples which we have proved and solved, and please go through them. Some are typical, some are easy, so you have to learn all these examples and practice them. So note down them in a book and keep them as to use them as a future record for your study. Okay, thank you.